All right, this is the notes for section 6.7, the quadratic formula. And the quadratic formula is going to be used to find solutions to any quadratic equation as long as it's in standard form. And it is also used to find the x-intercepts of any quadratic. Now, if you think about it, we've been able to find all the other key points or key properties of a parabola, except for the x-intercepts. This is how we're going to be able to do that now. So, what is the quadratic formula? I know you've seen this before, but if we have it in standard form where it's set equal to 0, then the quadratic formula is this right here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the plus or minus means that there's going to be two different values for x. If you think about a parabola in terms of its x-intercepts, there's generally going to be, if it's goes through the x-axis, generally it's going to have two solutions. Now occasionally it will have 1 or 0, and we'll talk about those cases a little bit later on. Okay. Some keys to using the quadratic formula is when applying the quadratic formula, your equation must be equal to 0. That's a key component. So if it's not equal to 0, you need to bring that over to the other side and set it equal to 0. You need to be able to identify what your a, b, and c values are. You need to pay attention to the plus and the minus. The discriminant, this part where it's b squared minus 4ac, if that's a perfect square, then we know that our solution is going to be rational. So those are some key components to the quadratic formula. Now what I want to do is take a look at some examples of this. And we're actually going to skip down and do example 2 next, and then we'll come back and do example 1. Alright, the reason why I want to do example 2 first is because it's a little bit easier, more straightforward problem. And it says the following. We want to solve 3x squared minus 10x minus 25 equals 0. So you'll notice that I already have this one solved for 0, and that really is helpful that we don't have to do anything else to it. We can just immediately pick out our a, b, and c values. So my a value would be 3, my b value would be negative 10, and my c value would be negative 25. Now I'm going to take those a, b, and c values and plug those into the quadratic formula. And it is just a matter of plugging things in. So remember, it's negative b, or the opposite of b. So if b is negative 10, this is actually going to end up being 10 instead of negative 10. Plus or minus the square root of b squared minus 4ac all over 2a. Now the first thing that I'm going to do is I'm going to work with the stuff that's underneath the radical, this stuff right here, underneath the square root. And if I simplify that, I notice that it's equal to the square root of 400. Now the nice thing about the square root of 400 is that that is a perfect square. And when I take the square root of it, I get the value of 20. So this right here is equal to 20. Now if I simplify that, that means that I have 10 plus or minus 20 over 6. And to get my two values, then I'm going to go 10 plus 20 over 6, which is 30 over 6, which gives me this value of 5. And then I also have to do 10 minus 20 over 6, which would be 10 over 6, or excuse me, negative 10 over 6, which is equal to negative 5/3, and that's where we're getting that value right there. So that's a straightforward example of using our quadratic formula. Alright, example 2, or example 1, excuse me, the second one that we're going to do is the more of a real life example. And it says, using the equation h equals this right here, to model the path of a ball, suppose an outfielder makes a shoestring catch and catches the ball when it is 2 feet above the ground. To the nearest foot, how far from home plate was the ball caught? Okay, so this is the quadratic that we're working with, but instead of h, we're going to be plugging in 2 for the height, because that's the height at which the player catches the ball. So this is what we have and that we're trying to solve for. So we want to solve this for x. Well, in order to do that, we have to first move 2 over to the other side. By bringing it over here, I'm subtracting 2 from both sides. So if I subtract 2 here, 4 minus 2 gives me this positive 2. So I've just rewritten this with my c value now being 2. So now I have my A, B, and C values that I can plug into my formula. So x equals, and now I've plugged those values in, and I want to simplify. Now don't just, sometimes people want to just go right to their calculator and plug that in. It's really best to kind of do it step by step. So go ahead and figure out the stuff underneath the radical first, which would be about 0.3076. And then I'm going to say negative 5.45 plus that divided by this, and negative 5.45 minus that divided by this. Now you'll notice that it gives us two values. One of those values is negative, and the other value is positive. Well, we know it cannot be the negative value, because if it were the negative value, that would be further behind where the ball was originally hit. So the only value that is possible is this 416.516. So what that means is that the actual answer to this would be that the outfielder caught the ball at 416.5 feet from home plate. All right, so let's take a look at this final example. In the final example, it says use the explicit formula t sub n is equal to n times n plus 1 divided by 2 for a sequence of triangular numbers. Is 70,876 a triangular number? Well, if it is a triangular number, what we can do then is we can put this in for t sub n. So I'm going to take t sub n out and put this in its place. And now really what we have to do is we have to solve for n and see if we get a value for that. All right, well, to do that, I'm going to first multiply both sides by 2. So that's what I'm doing here, multiplying by 2 on both sides, which gives me this right here. Now, remember, if I'm going to use my quadratic formula, what I have to do is I have to solve it so that one side is equal to 0. So I've got to subtract this 141,752 from both sides. So now I have, I have my equation solved so that one side is equal to 0. So I'm going to now use my quadratic formula, and you'll notice that my a is 1, my b is 1, and my c is this negative 141,752. Now I'm plugging those in. This stuff underneath here is a perfect square, and if I take the square root of it, I get 753. So now I'm just going to say negative 1 plus or minus that. Well, one of those values is negative 377. Well, we know that negative 377 cannot work because we can't have a negative value when we're doing a sequence. So my only possibility is 377, and since it comes out to be exactly 377, we can say, and that's a whole number, we can say that 70,876 is a triangular number, and in fact it's the 377th triangular number.